Today we're going to look at network design and pricing. And again, in this lab, I'm not going to show you the solution because there are many different correct solutions, and I want you to apply the skills and things that you've learned so far in the class to come up with a solution with your group. The first thing we need to do when designing a new network is figure out what the requirements are. How many wired connections does a business need? What are they going to use that network for? Is it video conferencing? Is it email? How much bandwidth do they need? Is there any security concerns they have? What space constraints? What does the floor plan look like? Do we have to run new cable? Is there existing cable? There's a lot of information that we have to gather from the customers. In this case, you're given the problem of designing and pricing the network for the White House. I picked the White House just because the floor plans were easily accessible and everybody knows what the White House is. But we're going to treat it like a regular business. Here's the requirements. We want 2 wired Ethernet drops per room. We need Wi-Fi. About 75 people per floor of the White House. And we have to connect to the internet. Straightforward enough. So we have to figure out how many routers, switches, access points, Ethernet cable we need, patch panels, and racks for equipment. So we need to price all of that out. The cable is going to cost $100 per drop. So a drop goes from the patch panel in your telecom closet to the wall jack. That's one line of cable. Now the actual Ethernet cable, that might, it might be 100 feet, let's say 100 feet of cable. That 100 feet of cable might cost a couple bucks, let's say $5. But we're still going to charge $100. We're going to charge our customer $100 because the labor to install that cable, that's the expensive part. Now this might seem expensive, but $100 is actually probably on the low end. I was talking to somebody who was reviewing quotes to run cable in a local high school, and the lowest quote for running cable was $160 per drop. So your cable can get expensive. Even though we say Ethernet cable is cheap, running the cable can be pricey. Now let's talk about some general rules. Here we've got 3 floors of the White House. Okay. How many routers do we need? A typical rule is 1 router per building. So every building's going to need a router. Just like, think about your house. Your house, you've got 1 router. You typically don't need multiple routers inside your house. A typical building, that router only sits at the edge of your network, and if that traffic needs to leave your network, that's the only time you're actually using it. So it's really just connections to the internet. So 1 router per building. So I'll put hardware. Model, we don't know what model we need yet. Quantity, we just need 1 router. Price per unit, we'll figure that out later. It's a question mark. Total cost. Okay, so we know we just need 1 router. How about switches? Well, we have to figure out how many switches we need. We need 2 drops, 2 wired Ethernet drops per room. And as you look at the schematic, it's not exactly clear what might count as a room. So the map room is a room, that's pretty clear. The diplomatic reception room is a room. We need 2 drops there. But what about these little side rooms? They look almost like closets or maybe even bathrooms. We have to figure out how many Ethernet drops we need. I'll do some quick estimation. Let's just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's say I count 23 rooms. So on this floor, we have 23 rooms, and I need 2 connections in each one, so I need 46 connections. I also need a couple spare, some uplink ports to connect these switches to other switches and the router. So let's see about that. I could get two 24-port switches that have uplink ports, and I could connect those to a main switch. I'll just assume, for argument's sake, cable drops. What did I say? I needed 46 cable drops just for this floor, for the first floor. It's going to be $100 each, so I'm just going to multiply 46 times 100. That's how much my cable just for the first floor is going to cost. And I'm not going to go through, I'm going to let you come up with your own number, so I'm going to fudge my number here. I'm just going to multiply this by about 3. I'll say I need 120 total drops. So I'm looking at $12,000 just for cable. Currency, no decimal points. So that's, it's quite a few drops. What other hardware do I need? Let's see, switches. If I use a 24-port switch with 2 uplink, like the 2960s we have in the classroom, how many would I need? Well, I would need equals 120 divided by 24. I would need exactly 5 switches. Would hit it right on the head. So if I say, I'll leave a little bit of extra room to grow. I'll put 2 switches per floor. I don't want to be at 100% utilization right from the get-go. So I'm going to have 6 switches per floor, but then I'm actually going to add a 7th one because I'm going to connect those 6 switches to a main switch and then plug that switch into the router. So let's look at what that might look like here. I'll pull up Packet Tracer just to do some quick diagramming. So on the first floor, I'll have 2 switches. So they'll have a capacity of 48 connections total, 48 drops into the rooms. On the second floor, I'll have another 2, and then I'll have another 2 on the third floor. 1, 2, and 3, top to bottom, bottom up, doesn't really matter. Then I'm going to connect all these switches to a main switch and then to a router. This is a fairly standard design. Some routers have lots of Ethernet connections and you can connect a bunch of different devices to that router. Most routers have very few interfaces. So I'm going to connect, this is essentially how it would look. I'm going to connect the gigabit 01 uplink port just to a regular switch port. In practice, this switch 6 right now, what I'll call my backbone switch, we would really, in the ideal world, want to use some beefy hardware. Here I'm just using another 2960 switch that's not super amazing, would get the job done. And so I'm connecting all of these, and then I'm going to connect this switch. I'll use its, oops, I connected one to the gigabit port. Which one did I do? Is it that one? Ah, nuts. Can't talk and click at the same time. So I'll pause my talking. Okay, I wanted to keep, okay, I use that uplink port to connect to the router. Of course it's red. I don't really care about the color right now. Now this is fine. This is the minimal design. If I wanted to add some redundancy here, I might actually add even another switch. Because if switch 6 goes down, my whole network is done. Nothing works. So I can add another switch for redundancy, and then I would connect these using the other Can't multitask, I apologize. Using the other uplink port, I will connect these to the switch. So uplink to regular, uplink to regular, uplink to regular. All right, now I'm going to use this uplink port to connect to the router 2. Okay, so this way, if one of switch 6 or switch 7 goes down, or if I have to do some maintenance on them, it can kind of fail over to the other switch. You can see spanning tree protocols working beautifully here. Most of these ports on switch 7 have been disabled so that all the traffic will be going through switch 6 if, oh, now they're on. Well, the ports are disabled on to switch 7 on the side of the access layer switches. You can see the amber lights. We could specifically disable or enable specific interfaces by defining what our root bridge is, but for now, I'm just doing the diagram. That's fine. Just know that these amber lights, they're okay. That means everything is working the way it's supposed to. These red lights, of course, are red because we haven't enabled those router interfaces. So in this diagram, with some redundancy, I actually have eight switches. What's my price per unit? I don't know. Let's keep going. We need wireless access points. So we need to support, a typical wireless access point will support about 40 devices. Even if they advertise that they support 100, in practice, talking to professionals, over 40 things start to go badly. So I need to support 75 people per floor. So I'm gonna put, oh, I don't need 6, I need 60, I need 6, 2 per floor. So 2 per floor would support 80 people per floor. In my end devices, network devices, I need wireless. I'm gonna have each floor will connect. Each of these access points will connect to one of my switches. Somewhere. So that's using up another connection on the device. I won't cable everything. That's basically what this would look like. So I'm using some of these switches for my access points. Most of them would be for the drops in the individual rooms. So I need 6 of these access points. I haven't figured out a model yet. All right, how about patch panel? If I get a 24 port patch panel, so how many in my telecom closet, how many cables are going to be running there? So all of these switches, we can decide. Usually 1 telecom closet per floor is good. Just as a rule, if you can do that, that's fine. Like, we're going to steal one of these rooms next to the map room to be our telecom closet. So on 1 floor, all these cables are going to be running there. So we'll have 24 running to each switch, plus 2 more going to our main switches. So we've got, 52 per floor. So we're going to be looking at a bunch of cables. So we have to support, let's say, 150 cables. So if we have 150 cables and we're using 24 port patch panels, 6 and a quarter, well, you can't buy a quarter patch panel, so we'll buy 7 patch panels. So we'll put 2 patch panels on every floor, about 1 per switch, and then we'll have another one in our main Telecom Closet to support all these extra connections and our router and everything. So we got to buy 7 of those, and we need some equipment racks. We'll have 3 Telecom Closets. I'll say we'll need 3 racks. Okay, so we haven't priced anything. To price this hardware, let's go to Newegg, newegg.com. Newegg's been around forever. It used to be Egghead Hardware back in the 80s. When I was building computers with my dad, we would drive to Newegg. We would get the weekly mailer, go there, go spend a couple $100 on a megabyte of RAM putting together these old computers. That old Egghead hardware was reborn in the internet age and it's now Newegg. Everyone who builds a computer knows about Newegg. You just shop there. You just do. They have excellent customer service. That's one thing. If your hardware doesn't work, send them an email. They fix it right away. I'm going to come here to networking. Let's look at routers first. We don't want home networking. For our purposes, our business, home networking does not exist. I want a wired router. Now, you have to use your judgment here. Which router is going to be good for you? So we can go with the TP-Link. This is Mr. Cheapo router. Not super powerful, but it does have 4 gigabit wired connections. Like, we really only need 2 wired connections. This has got a firewall, so some security, some VPN pass-through. So it does some good stuff. It might not scale to what we need, so we just have to shop around. You have to use your best judgment. If I went to the White House and I said, yeah, we're going to use this TP-Link router, they might scoff at you. I want something pricier. Let's see. Let's go with Cisco. We've used Cisco's gear so far. Okay, so this is more expensive, clearly. Here we've got a 1921 router. So we're using 1941 routers in class. Hard to tell what you need, right? I mean, this thing looks cool. License-free web filtering. All right, I'm sold on the web filtering. I'm just gonna say, without digging in, let's use the RV 340 45. I'm gonna put a link here. Price per unit, we're looking at $353. Okay, so our router, important piece of equipment, it's going to cost us $350. It's a fraction of what our cable is going to cost us. So let's look at switches. Oops. I'm going to come back to networking. I'm going to look at commercial networking switches. And I want 13 to 30 ports. So here's the ports I want. Gosh, there's a lot. So 24 ports are very common. So this is basically 24 ports and 2 uplink. So this is really what we want. So all I want is that. Can I uncheck all? So these don't show any uplink ports. Apply. Okay, so you see, like with this Ubiquiti router, we've got 24 ports and then 2 uplink ports. These could be fiber. We can configure them to be fiber, or they could just be Ethernet. You essentially have to figure that out kind of on your own. This is an unmanaged switch. Zyxel, your X, we want to manage switch. We want to do fun stuff with this if we want to. Let's just go with this one. So this will be the Cisco SLM224PT-NA. So smart PoE, power over Ethernet. So this costs $261. So we're going to spend $2,000 on switches. What are we going to look for? Wireless access points. We're using Cisco stuff. Let's go with Cisco systems. 1,000 options for switches. I'm just going to pick whatever the first one is just to make this video shorter. I know this is fascinating watching me do this. Costs about $71 per unit. Oops, I didn't copy the link last time. Patch panels. So where am I going to find that stuff? Networking. Am I going to find it here? Where would it be? Patch. Yeah, I'm just going to search. Patch panel. First one, I'm going to buy it. All right, TrendNet. TrendNet TCP24C5E. The best patch panel in the universe. These should be pretty cheap. 30 bucks. All right, 210. Now I need some equipment racks. Yeah, that one looks good. First one there. Grip Light SRW12US. Does it come with a lock? Looks like it might lock. That I care terribly much about that. $324. It's kind of pricey for a network rack, but hey, it's for the White House, right? Spare no expense. So you'll notice one thing: we've got all of our hardware here. So I'm going to come up with a total cost just using my assumptions. And again, I did not do a thorough job because I don't want to tell you the answer. But here's a rough estimate of what this equipment is going to cost. Notice I did not price labor into this, like to configure, to install the patch panels, anything. The only place where I may have indirectly included labor was in the price of the cable drops, because much of that $100 ballpark figure is labor. But you don't need to include the cost of that labor. Really, here we're just focusing on hardware. If I was pricing labor, you know, I might bill at $80 an hour. So how much time is it going to take? I don't know, 200 hours to do everything, to troubleshoot, to build it all out. I might charge support. I might charge them $100 a month for support on a support contract, so if something goes wrong, they can call me. There's other things I could factor in here, but for the purposes of this exercise, we're just looking at the cost of the network here. So let's look total cost. My network costs $16,000. If yours costs $160,000, that would be okay too. If you just get the best of the best hardware, the best of the best everything, that's feasible. If it's a whole lot less than this, if your network costs only, you know, $2,000 or $3,000, probably didn't go through it thoroughly enough. As far as cable go, look at the cable again. $12,000 of $16,000 is just Ethernet cable. So again, when people say Ethernet cable is cheap, you have to put that in perspective. Fiber would cost a whole lot more and would be more difficult to work with, but the cable is not an insignificant cost. For some people's semester cases, they look at the line, they assume they've done something wrong because their cable budget is in the high tens of thousands or in the six-figure range. But nope, that's just the way it goes. So I've come up with basically a design, the design of my network Here, I haven't defined any IP addresses or VLANs or anything. I would want to do that as I go to start configuring everything, but here I'm just focusing on getting the right amount of hardware, and this should do it. So that's the process that I would follow. Figure out what your requirements are, figure out what hardware you need to buy to support those requirements, figure out which hardware you're actually going to buy, and estimate the cost, and that's what we come up with at the end. So we should have a table that looks roughly like this. Yep, and I did produce that in Excel. Other things that we want to answer is, what internet service provider are you going to choose? Where are we going to put the telecom closets? Where are we going to put the router or routers? I put the S in there. Really, it should be one router. And then submit that spreadsheet. Everyone should create this spreadsheet. You're going to do this on your semester case anyway, so just have that handy. Make sure everyone's on the same page. All right, I'm excited to see the estimates that you come up with in class to do network design and pricing.